are you? My name is Gabe Hollenby. I am a senior developer advocate here at Amazon Web Services. And I'm coming to you from our studio here in Singapore. Thanks for joining us for today's AWS Builders Online series. We've got a great program set out for you today. In this opening session, I'll do my best to sort of lay the foundation with some basic knowledge that you should have no matter what you're going to do on the cloud. And then after this, we have some Q&A with experts and then a lot of really specific tracks for you to dive into afterwards. But I want to start with some basics about what the cloud is and why people come to the cloud and why we see so many companies from small startups to large enterprises transform themselves and build on the cloud. And you'll notice that there's a lot of different value propositions up here, and I'll just quickly touch on each of them. Lowering costs is one that people think about the cloud and they think about lowering costs. And that makes sense because what the cloud lets you do is it lets you trade capital expense for operating expense. Instead of the traditional ways where if you wanted to deploy some new service, the first thing you would do is buy a bunch of servers and rack them up in a data center somewhere in this large capital expense. Now what you can do is you can provision servers on demand or plug into existing services that we offer on demand right when you need them and then only pay for the resources you use. So changing that capital expense, the huge capital expense upfront for a variable operating expense is a really nice value proposition that a lot of companies are attracted to the cloud for. But you come for the lower costs and you stay for all these other reasons. Increased agility is a very important thing that happens as a result of cloud computing because instead of having your teams need to wait for those physical compute resources to be purchased and racked up in your office or your data center, now if your teams have a new idea for something they want to innovate on, they can provision 1 or 10 or hundreds of servers in the cloud on AWS in minutes and try out their idea immediately. And if it works, that's great. Congratulations, your team's innovating. And if it doesn't, they can rapidly try new ideas and spin down the failed experiments and shut those resources off, and then you're only paying for the amount of resources you consumed for that particular period of time. So that really unlocks a lot more rapid iteration cycles and increases your company agility. Scalability and reliability also come hand in hand with the cloud. In order to allow customers such amazing flexibility for being able to spin up these resources on demand, for example, AWS has an enormous fleet of compute and resources and other services available for customers to make use of. And there are certain lessons that you only learn as a cloud provider when you've been in the business as long as AWS has and when you've reached the scale that we've had. And so the scalability lessons that we've learned allow all of our customers to leverage that scalability and that increased reliability that we've learned and that we've earned in all of our years of operating today. But underlining all of this is raising your security posture, right? This is really important. We talk about security being job zero at AWS, and it should be job zero anywhere. And what we mean by that, it should be the first thing that you consider in the services and the solutions that you're building. And so what I want to do in this opening session today is set out for you the basics that you need to know, no matter what kind of solution you're planning on building in the cloud on AWS. There's some fundamental basics that you should know about security in the cloud to make your workloads run securely. So here's the agenda. I'm going to start with a builder-focused introduction to AWS's security controls, and that's what we'll spend most of the time in today's morning session on. I'll quickly cover the differences between what AWS takes care of on our side and then what you're responsible for. We have something called a shared responsibility model, and I'll dig into that in a few minutes. And then I will teach you how to control your cloud infrastructure, how to control your data, and how to control your network using a few key services. And finally, I'll cover an overview of what to expect for the rest of today in AWS Builders Online. And thanks for staying with me. Let's get going. So, cloud security is a shared responsibility. What that means is that there are some things that AWS is responsible for and some things that you're responsible for. We talk about this as security of the cloud versus security in the cloud. So security of the cloud, this is things like the physical security of the data centers that comprise AWS's infrastructure on the world, as well as the networking capabilities as well. Whereas security in the cloud, this is things like the operating systems security. If you provision your own virtual machines, you'll need to make sure the operating systems are fully patched and up to date on any virtual machines that you're running. You're responsible for configuring the network security policies on those virtual machines. You're responsible for configuring security policies for identity and access management with the resources that you use in the cloud. Your customers are responsible for the security of the code that they write in the services that they're deploying onto the cloud. Whereas any services that you use of AWS, we're responsible for the integrity of the services we offer to you. So I hope that makes sense as far as a difference of responsibilities. And we'll explore those more in a bit more detail now. So let's look at the parts that you don't need to worry about. Security of the cloud, the stuff that AWS manages. So at AWS, Amazon Web Services, we do what it says in our name. We offer services through the web for customers like you to use. And what that means is that we have a lot of services running on computers somewhere, and those computers have to live somewhere. And those computers live in what we call availability zones. These are the smallest atomic unit of our networking infrastructure around the world. And these availability zones are comprised of 2 or more data centers, physical data centers, that have redundant power, redundant networking between them. They have redundant, independent and redundant power on their own sites. And they've also got redundant networking between them. And the networking that connects them is all encrypted. And what this means is that using this construct of availability zones, you achieve high availability. Because in any particular location, you can deploy resources into different availability zones such that if there were to be, let's say, a disaster in one particular cluster of data centers, it wouldn't affect, or it's designed not to affect ones and the other ones, right? They're separated by enough distance that things like floods shouldn't affect each other, but they're close enough that the interconnect between them, the networking interconnect that they have between each of them is fast enough to allow things like very fast data replication. For example, you might have a database server, and you might have a primary in one availability zone and a secondary in another one. And you want to have data replication between those servers such that if there was a problem in one availability zone, you could fail over to the other one and still have all your data. And the reason why we separate them at this distance is, again, to find that right balance between basically independent units of physical location and the dependability to have that data communicate quickly with each other for the purpose of synchronizing data. We maintain the operational security of these availability zones, right? So these physical sites, that's not something you obviously need to worry about. And we also maintain the network security of the interconnect between them all. Now, all of these availability zones together comprise a region. So in a particular city, a location somewhere, we have multiple availability zones. And those multiple availability zones roll up to a region. And we have regions all around the world as represented by this map. So today, at the time of this session, we have 24 regions with 3 more announced that are up and coming. We have 77 availability zones across those 24 regions. And then we have something called points of presence. Our network points of presence, or POPs, are how we have a content delivery network, even broader reach around the globe, letting you put content closer to where your customers are geographically so they can have the best possible customer experience when they're accessing your services. And so between our 24 regions and 77 availability zones and today 216 network points of presence, we have a truly massive global network. And all of our AWS regions are also connected together, and traffic is encrypted between them on our own networks as well. So the data transfer between regions is really quite fast. And something else you should know is that your data will never leave an AWS region unless you configure it to do so. So if you want cross-region replication, for example, that's something you can opt into for a number of services that we have. But that's something you opt into. Otherwise, data that you create in your availability zones in a particular region will stay in that region. So that's our global infrastructure. And we also have a number of security certifications and compliances that from a number of different security providers and auditors, third parties that have standards that we need to meet. And this is one of my favorite things about AWS. The most security-sensitive customers, the things that they demand the most, we meet that, but every one of our customers gets to benefit from that because we don't develop features or capabilities for only a particular customer and make that available only for one customer. What our most security-sensitive and demanding customers want, all of our customers get. So you get to benefit from that even if you're not, let's say, an international bank, for example. This slide has over 30 different compliance programs and certifications that AWS has earned. And so more than any other cloud provider, you can really trust that your data is safe on AWS and that we really meet and raise the global bar when it comes to compliance and governance standards for workloads, whether it's in finance or healthcare, retail, government, and beyond. So that's security of the cloud. Those are the things we take care of. Let's talk about security in the cloud. These are the facets that you need to be responsible for. If you look at this list, this is a screenshot I took of the AWS console. You'll see it's quite big. There's a lot of services here. And that's not even all of them because I didn't scroll all the way to the bottom. You might look at this and think, oh my gosh, that's a lot of services. I need to learn how to secure all of those that I'm going to work with. Well, you should know how to secure them all, but the great thing is you don't have to learn different ways for each of them. In fact, there's just a few essential concepts that you need to understand in order to run your workloads securely in the AWS cloud. And that's what I'm going to teach you today in the duration of this session. So we'll start with talking about permissions management with AWS Identity and Access Management. Following that, we'll talk about data encryption with AWS Key Management Service, or KMS. And finally, we'll talk about network security controls with Amazon's Virtual Private Cloud, or VPC, as we often call it. And with just these three pillars, you can operate any workload securely. So let's talk about IAM first, or Identity and Access Management. No matter what you do in the cloud, all of that doing has to involve two things, a who and a what. Who, what entity is trying to do something in the cloud, and what is that entity trying to do? And that's governed by AWS's Identity and Access Management. The I stands for identity or authentication, right? Who. And the AM, the access management, stands for authorization, or the what, right? What are you allowed to do? So no matter what you're building, as a builder, what you need to know is that every AWS API call is authenticated and authorized with IAM. So I'm going to teach you how to make authenticated API calls to AWS from IAM identities. I'll then teach you how to establish a basic fluency in the policy language that IAM uses to describe the permissions for what your identity principals are allowed to do or not allowed to do. And finally, I'll teach you where to find and understand the documentation for each of our services and any particular actions that you want to govern in an identity policy for a particular service. So let's start with the I part, identity, in a bit more detail. There's a few different types of identities on AWS, and the one that's easiest to understand is you and me, human identities, right? This usually takes the form of us logging into the AWS Management Console here with a username and a password. Or as developers, we might have been given, or we might have generated ourselves, some credentials, a key pair, a set of AWS secret access key and access key ID. And that combination of those things you can use from programmatically from the command line interface or through one of our programmable SDKs to interact with AWS. And again, that's all authenticating you as a particular human with a set of long-lived credentials. So that's one way we can find out who you are, and AWS will track the identity associated with that particular user if you come in that way. But there's another way that human beings can interact with AWS, and that's through federated identity systems. So a lot of companies might have their own corporate directory, as you can see here. And for example, we might split up who's in that corporate directory by their roles. Right? We have administrators and we have developers, let's say. And even the name role, it fits really naturally into that, right? These kind of groupings of people. What role are they playing in the organization? So similarly, in AWS, in IAM, we have a concept of what we call a role. And a role, the construct of a role is very similar to just a human user, except not only humans can use them. So It's another place where we can hang policies, and I'll talk more about policies in a minute. So we can attach policies to a role, and humans can then assume that role in order to get work done on AWS. And that could happen, again, through some federated identities that control what roles particular users are allowed to assume. Or it could be from non-human callers also. So if you've ever spun up a EC2 instance, Elastic Compute Cloud, our virtual private servers, or if you've used AWS Lambda before, our functions as a service in the cloud, you probably noticed there's a part in the wizard, if you use the GUI, where it says, do you want to, well, in the case of EC2, it allows you to optionally associate an AWS IAM role with that EC2 instance. And in the case of Lambda, you're required to pick a role. What role will this Lambda function use when it executes? So many services on AWS will use a role in order to execute whatever they're going to do when they're going to make cross-service calls. Now, EC2 instances, Lambda functions, a few other popular ones, SageMaker notebooks, glue crawlers, or ECS tasks, just to name a few. And so it's important to understand that most of the work you might be doing in IAM at the beginning will probably involve a combination of roles that humans assume and roles that services assume in order to get work done in the cloud. So how do we create roles? It's actually very easy. This is a screenshot from the IAM Management Console. And the first step you need to do is decide what type of identity is going to be using this role. Is it going to be a role for a non-human process? This will be from an AWS service, like you just saw in the previous slide. Might it be a role for cross-account access? So this would be maybe somebody in a different AWS account, some identity in a different account that you want to allow access in to your AWS account for some reason. So you can do cross-account authentication. Or is this going to be a role for federated identities, whether that be a web identity through OpenID, for example, or a federated identity through SAML 2.0 federation. And so once you know what type of role you want to make, and most of the time when you're just getting started, you're going to be creating roles for AWS services. The next step is you get to attach policies to this role. And to start you off, we have a number of pre-written policies that you can attach. These are AWS-managed policies. And you can look them up by name, and you can expand them and view what the particular policy declarations are. And here's a few in this screenshot. You can see here, for example, there's one at the top that says administrator access. If you give a role the administrator access policy, then any identity that's going to use that role, that's allowed to use that role, can do anything in your account. So probably not the role that you want to associate, or the policy rather, that you want to associate with most roles, but it's there if you need it. And again, there are a number of more granular roles as well there. And you can browse those and become more familiar with them. But I actually recommend that for most of the time, you should craft your own IAM policies, because it's not only fairly easy to do, but it also gives you a better security posture. So let me teach you the basics of reading and writing IAM policies. They all start with an effect statement that's either allow or deny. Then they have a section for actions and a section for resources. So the action section says, what can or cannot you do? And the resource section says, what can or can't you do it to? So in English, for example, this policy is talking about DynamoDB. This is a NoSQL database service that we have. It's very popular. I had to pick some service here, so I'm just using DynamoDB. But you use IAM policies to govern access to any service that you're using on AWS. So this particular policy says, this role is allowed, or I should say anybody that has this policy attached to them is allowed to take all Amazon DynamoDB actions on any resource. But we can, and we should, write more specific policies than this. For example, instead of a wildcard asterisk action for the action section, here we've added a few specific actions instead. So in plain English, this policy says that you're allowing only a few specific DynamoDB actions related to reading data: batch, get item, and query. So just some read data. So if you have an application that only needs to read data from DynamoDB, this would be a better policy than the other one, because the other policy said any DynamoDB action, which would have meant the ability to write or delete things as well. Again, though, we're not limiting what resource this policy applies to in this example. This would mean any DynamoDB table, for example. So we can and we should be more specific yet again. So here's another one. In this particular version of our policy, as we've evolved it, this is really what we should aim for in the kinds of policies we write. We're going to be specific with the actions and specific with the resources. So we've added some ARNs, or Amazon resource names here. And these are the identities that all the AWS services use to describe particular resources in AWS. And they all follow this format. So you can see here, it says ARN, and then some other stuff, AWS, a scope, and then a service name, and then a region, then an account ID, and then some other stuff. In this case, a particular table in DynamoDB, and all of its indexes. So this policy says, I can only do these 3 actions related to reading from this one particular DynamoDB table. This is the kind of policies I want you to write, because it's following the the principle of least privilege, which is a really good practice in the policies you write, so that if you put this in a Lambda function and somebody else has access to the Lambda function that you didn't realize because of something you maybe didn't configure the way you intended, the blast radius is limited, right? The Lambda function is only allowed to do these actions. So you always want to be as specific as possible with the actions and the resources. There's one more neat thing you can do. Some services support variables in their policy statements. So this uses something called attribute-based access control. And in this particular example, what we're saying, we're leveraging the fact that identity principles in IAM can have tags applied to them. And some resources in some AWS services, in this case, Secrets Manager, a service we have for, unsurprisingly, storing secret data, can have tags applied to them too. And so what we can say here is, you can read secrets if the project tag of that secret matches your own tag for that project. Right? So if you're tagged for a particular project at a principal identity level and a secret is tagged for that same project, then you're allowed to read it. So this kind of gives you a little layer of abstraction where you don't have to have all of the specific resources in the document, in the IAM policy. Instead, you can also put some dynamic conditions in place. Really useful thing to know about. So you might be thinking, OK, Gabe, that's great. How do I know what actions I'm allowed to specify for a given service in the policies I'm writing, and which services support what types of attribute-based access control? Well, the answer is we have all of this extensively documented on our website. And you can take a look there. For every service that we have, you'll learn how to read the table for all the actions you're allowed to use, and what types of attribute-based access control exist for each service. So you can check that out. And that's it. That's the basics of identity and access management. So now you know how to authenticate and authorize the identities in your AWS account. Next, let's move on to keeping your data secure with encryption. And we do this with AWS KMS, or Key Management Service. So what is KMS? It's AWS managed encryption and decryption for you. And why you should care is that many of the data handling services that AWS has give you really simple KMS integrations to help you keep your data encrypted at rest. And if you know how to use KMS, you can protect your data at rest really easily with no management overhead. So as a builder, what you need to know is the basics of how to use an AWS KMS key. I want to familiarize you with the KMS integrations offered by many AWS data-specific services, and how to use IAM to control access to KMS keys. So let's use a specific example. Now, it's OK if you don't understand what I'm about to show you. But it's a builder session, so I want to at least explain what's going on behind the scenes before I explain why you don't need to understand this. So bear with me for just a moment. Here's how AWS KMS works. Let's say you have a particular key that you've already generated. This is just a cryptographic key. So that's stored in KMS. Now you want to encrypt and decrypt data with that key. So you can use the simple API, KMS encrypt and KMS decrypt. You can use those calls to encrypt and decrypt data. And that's fine. You pass in the data you want to encrypt or the data you need decrypted, and you get back the ciphertext or the plain text. And you can do that for up to 4 kilobyte chunks of data at a time. But let's use an example. Let's say you've got some objects in Amazon S3, our simple storage service that gives you virtually unlimited cloud storage. And let's say that you want to keep those objects encrypted at rest. So how could you do it using just these API calls? Well, your service, that's before it puts the data into into S3 could take the data and it could do something called envelope encryption, which says, all right, I'm going to use the KMS generate data key API call, which will create a symmetric encryption key. And it'll create a plaintext and an encrypted version of that key. And it will use the plaintext version of that key to encrypt all of your data that you want to encrypt in 4 kilobyte chunks. And then it throws away that key. And then it'll store the encrypted data key alongside all of the encrypted data. And then when it comes time to read that, and then you would store that on S3, for example. And when it comes time to read that data out, you get back that envelope encrypted data, and you would use the KMS decrypt API call, passing in the encrypted data key that you fetched alongside the encrypted data. And that gives you back the plaintext data key, which you would then use to decrypt the data in those 4 kilobyte chunks. It's actually not that complicated, but it's still a lot of undifferentiated heavy lifting that you shouldn't have to do. And it turns out you don't. You don't need to do it. Why don't you need to do it? Because KMS will manage the mechanics for you. Right? Other services know how to integrate with KMS and do all of that for you behind the scenes. So let me show you exactly what that looks like in practice. So here I am, a screenshot of the S3 web console. I'm making a new bucket, a place to put my objects. And during the create bucket step, I have the option of checking the box to say automatically encrypt objects that are stored in S3. I want that. I want my data encrypted at rest. It's very easy. I can check the box. And if I don't do anything, it'll default to using a key called Amazon S3 Managed Keys. So that's a key that S3 manages for me. It's not stored in KMS. I don't have to do anything. I never have to think about IAM for it because S3 is managing this key. And I can have data encrypted at rest just by checking the box and leaving that first option checked. But let's say I want a little bit more control over who's allowed to, what identities are allowed to decrypt data or even store data encrypted in that bucket. If I want that, then I should use KMS. And so this will use a customer managed key, right? A key that I've stored in the KMS service already to encrypt and decrypt my data for me. And all I need to do there is find a key that I've previously created in KMS and select it here in the wizard. And if I do that, then all of my operations to S3 are going to be, S3 behind the scenes will take care of that encrypting and decrypting for me. Pretty nice. But let's look at a detail that we need to be aware of when we're using KMS encryption with the service integration. And that is we need to make sure that the policies account for that as well. For example, let's assume we've set up my bucket just like you saw in the previous slide, and I'm using a KMS key to encrypt data in that bucket. And let's say we have a role that has this one policy, allowing S3 get object for any object inside my bucket. So what's going to happen? Is this policy enough in order for me to get the data out? Well, it turns out it's not, and here's why. This policy only allows me to get objects out of S3. So that means that the S3 service, it's going to be able to pull objects out of the bucket, no problem. But it's not going to be able to use the KMS to decrypt the contents of that object. So that part's just not going to work, which means, of course, that the whole call isn't going to work. Instead, we need to update this policy. So we've still got the same initial policy that we had before. And that'll allow us to fetch the contents out of the bucket. But let's add another policy here, another statement rather to this policy that says, I'm going to allow KMS decrypt capabilities, that action, using a particular KMS key, the one that I know that the S3 bucket was configured to use. And if I add that statement to the same policy, then now we're able to also decrypt the data that we got out, and this call will succeed. That's it. So the advantage there is by using KMS, I can control not just the fact that the data is encrypted, but which identities are allowed to decrypt that data. And you might want that control. That's why KMS is there for you, to give you that extra layer of control. And it's not very complicated. You've seen everything you need to know in order to start using KMS there. So now let's move on to the last pillar that I want to teach you about today, which is Amazon Virtual Private Cloud, or what we often just call VPC. So what is a VPC? So a VPC is sometimes described as your virtual data center in the cloud, but I don't think that's a great explanation. I would say A VPC is a virtual network that you put resources in AWS, and that virtual network is segregated completely from anything else. And you have to control a lot of the specifics of how that virtual network is set up. But with that control comes some great capabilities to increase your security posture. So what you need to know are the core concepts about a VPC, and that's basically subnets and security groups. I'll teach you the routing basics about VPCs. And finally, some private connectivity options that will let you keep the different resources in your VPCs from communicating with, let's say, the public internet if they shouldn't. So what is a VPC and what goes in it? Right? A VPC gives you a logically isolated section of AWS where you can put resources. And if you remember at the beginning of this talk, I talked about regions and availability zones. So you have a region. A region is comprised of availability zones. And when you make a VPC, that VPC lives in a region, and you create subnets inside that VPC. The subnets are composed from chunks of an IP address space. So when you create your VPC, you pick an IP address space that you want to use. In this case, I'm using something called CIDR notation, CIDR, and that's just a way to shorthand express IP address ranges. So here I've said 10.0.0.0/16. So this is quite a big address space range for me to work with. And then I'm going to that's what my VPC has. I'm going to carve that up into a number of subnets inside this VPC. And I'm going to call them public and private subnets. And for now, those are just names. Okay, let's say there's nothing special that made them a public or a private subnet. By virtue of the fact that they just are named that, I'll show you later how we make them so. And so I'm using different versions of the IP address, different sections of my CIDR block, my VPC CIDR block, to carve out these different subnets inside each availability zone. So you can see here, each availability zone has a public and a private subnet for my VPC. And now let's put some resources inside of these subnets in my availability zones. This is a typical, a multi-tier application where, let's say, we've got a web app, and that consists of some kind of load balancer on the front end. And that load balancer is I want to route requests to that load balancer to a fleet of application servers that are going to actually implement my application, my web app, whatever it is. And in order for the web application to do its work, it's got compute happening on EC2 instances, but let's say we also have a database, and we're going to use Amazon RDS, our relational database service, for that. In this particular example, we want this all to be highly available, right? So I talked before at the very beginning about how you achieve high availability through the concept of availability zones. And the idea there is when you deploy resources on AWS, you want your application to span multiple availability zones in order to tolerate the loss of a problem in an availability zone should something like that occur. And AWS makes it very easy. So here I have instances of my application load balancer in each AZ. I've also got a fleet of EC2 instances in each AZ. And then I've got a primary database in one availability zone and, let's say, a secondary failover database in a different availability zone. It's important that they are also in different AZs for disaster recovery capabilities. And let's say I want my customers to be able to talk to my application through the public internet to the load balancer. And the load balancer should talk to the EC2 instances. EC2 instances should talk to the RDS database servers. That's it. How do we keep this network secure is the question. So if you understand only one thing about VPCs, let's make it this. VPCs have something called a security group. A security group is a virtual firewall that lets you govern the rules for communication in and out of a particular group of resources inside of a VPC. As you can see here, we kind of have three logical groups. So I've made three security groups. One for the application load balancers. These all have one role, and that is to fulfill requests from the public internet. We have a security group here. I've put all of my EC2 instances in a security group related to just serving the back end of the web application. And then I've got my databases in yet another security group here, because the concern there is just serve the database, right? Each of these types of resources have different security constraints that I'd like to impose. And this is security groups of the construct that make that possible. So what I want to do first is I want to allow traffic from the public internet into my application load balancers. And I'm going to do that by creating a security group. I'm just going to call it public-facing load balancers. And each security group has a unique ID here. And I only need to have one inbound rule on this group. And that is, I'm serving encrypted traffic, HTTPS traffic on TCP port 443 for the entire internet. So this notation, 0.0.0.0/0, just means any IP address. So this security group has one inbound rule. You can also put outbound rules into security groups, but I'm not going to cover that in this session. A neat thing to know is that security groups are stateful firewalls, and so they're just governing the initial connection, which means, in this case, if somebody's allowed to connect in from the public internet because of this rule, because the inbound rule, that's enough to let the entire bidirectional communication happen when the application load balancers give a result back. So there's that. That's my first security group and my first rule. I only have one rule in that security group for my load balancers. Next, I've got my backend web servers, right? And I want to be able to communicate from my front-end application load balancers to my backend instances. And so the way I'm going to do this is with a slightly different rule or different concept. Instead of identifying an IP address, I'm going to logically identify the security group source that I want to allow requests to come in from. So that's really neat. I can use security groups to group together resources that are related to each other, and then allow all of those, based on their security group ID, in this case, to come in. So let's assume that I've got local application servers running on HTTPS port 8443 on my backend instances. So I'll say I want to allow traffic into them on port 8443 only to members of the security group SG blah, blah, blah. That was the ID from this security group for my application load balancers. That's it. I'm only going to listen to load balancer traffic coming in on that port. Nice and simple and just that one rule. That's all I need. So that's all I'm going to put. Finally, we've got the fact that we have databases, and we only want the databases to listen for connections that came from the security groups for our EC2 instances, right? And the way we'll do that is with a similar thing. We'll use the security group ID from the EC2 instances security group that we made, the backend instances. And in this case, our database server is running MySQL Aurora, which runs on port 3306. So we'll allow only the inbound traffic on that port to the database from our backend instances. No other resource should be allowed to talk to our database server. Why? Nothing else needs it in this case. So we're going to keep it nice and restricted that way. So that's all this works. It's actually pretty simple, as you can see. You group your resources in your VPC together into security groups, and then you define rules allowing the inbound and outbound traffic for those security groups as are appropriate to whatever you're deploying. Now, there's something we haven't talked about yet related to routing, and that's what I want to touch on next. So we're done with security groups, but now let's talk about what made our subnets private versus public. Okay? So let's look at our private subnets here. The reason why they're private is because every subnet has a routing table associated with it. And in this case, the routing table that I'm using for these subnets has only one routing rule in it. It says, I want to route traffic for this VPC only, which means anything inside these private subnets, they're allowed to communicate, assuming the security groups will let them. They have the network routes to talk to anything in the VPC. That's great. They don't have permission, they don't have a route to the internet anywhere, so they won't be able to talk to the internet. That's really good. If they don't need permissions to talk to the internet, I shouldn't give them permissions. But what if we do need something to talk to the public internet? And we do, because we have these public subnets. So what makes them public? Well, what makes them public is that we have the same rule before that you saw, that local rule saying route traffic inside the VPC. But if the traffic doesn't match that pattern, then it'll look for this next routing table rule, which says traffic anywhere should go out to this thing called an internet gateway. This is the internet gateway ID here. So an internet gateway is something that you can put inside your VPCs, and it gives you the ability to route traffic out to the internet and receive traffic in from the internet. So my application load balancers that are in this public subnet, that's what makes a subnet public, and that's what allows this all to work. Now there's another construct I haven't shown here called a NAT gateway, which is a similar thing to an internet gateway for public subnets. If you had resources in your private subnets that needed to talk out to the internet, then you could create a NAT gateway and have a routing rule for that in your route tables of your private subnets. But I'm not going to show that here, because I don't need it in this particular example. So that's it. With that, that's how we made our subnets public or private. But there's one more thing you need to be aware of, and that's not all of the AWS resources that you create or want to communicate with are going to live inside a VPC. When I make an S3 bucket, for example, there's no place where I can say, which VPC do I want that bucket to live in, because the service doesn't live inside a VPC. And you can learn this yourself. If you do a DNS lookup for any of these services, for example, and there are many others, these are just a few, you'll see a public IP address. That's not an IP address inside of my VPC. So what if I want my traffic in my VPC? So what if I want my resources inside my private subnet to not need access to the public internet in order to route to that IP address to talk to these other services, right? How can I do that? What if I want to communicate securely with S3 from my backend instances in my previous example, but I don't want to give them a NAT gateway because there's no other reason for them to talk to the internet except maybe because I need them to talk to S3, for example. It turns out we have another construct called a VPC endpoint. So in this example, we've created something called a VPC endpoint. Now, many AWS services have VPC endpoints available. And what they let you do is they give you VPC local IP addresses in each of your subnets. You can see here, right? These are different IP addresses for a particular service, in this case, CloudWatch. So the example here is I've got a CloudWatch logs agent running on each of these EC2 instances, and I want to publish log files on my virtual servers up to Amazon CloudWatch so that I can aggregate and filter and search my data from across all my services in one centralized place, namely CloudWatch. So I can do that, but I don't want these private subnet instances to be able to talk to the internet, so I can create a VPC endpoint for CloudWatch and route my traffic through those. Now what's really neat is I don't need to update my application code at all. So if you have a VPC endpoint in a particular subnet, then we do some DNS magic for you. So when you look up the same service DNS name before, this time you'll get that VPC local IP address instead. Pretty nice. And so finally, bringing this full circle back to the S3 example, there's one nice thing about VPCs additionally, which is that they give you another ID that you can use to hang some policy statements off of. So every VPC endpoint has its own ID. And we can add another condition to our policies, for example, to say, I only want a particular role to be able to access a particular resource if the request comes from a specific VPC endpoint. And this is amazing, because this lets you say, not only do I have a particular identity that I know I want to restrict access to my resource on, but I also can say, I know that request from that identity must come from within inside a particular VPC. So that's a really great way to prove that nothing else no other services, even with that same role from a different VPC, can access that data. Really, really valuable to know how to do that. But it's really simple. So that's it. You made it to the end. Congratulations. Let's just review what we covered, because you know everything you need to know from a basic perspective to start running your workloads securely in the cloud. We started with IAM. We learned that identities are these things that can make AWS calls. We learned how to write and read IAM policies that we can attach to those identities, like roles. We also learned about AWS KMS, our key management service, and how it integrates with AWS services. We also learned how to authorize access to KMS keys from IAM policies. And finally, we learned how to get least privilege connectivity into our VPCs, our virtual private clouds, and we learned how to use our network as a security perimeter. I want to remind you that we have the shared responsibility model when it comes to security, and this slide just wraps it up a little bit more in more detail. So again, what is AWS is responsible for security of the cloud. That means all the software services that we offer around compute, storage, database, networking, all those services will make sure the services themselves are secure, highly available, and all of that. We also make sure that the physical integrity of our regions, our availability zones, and our edge locations are all secure. As a customer, you're responsible for security in the cloud, and that's going to cover things like making sure that your data, your customer data, is encrypted if you want it encrypted, for example. Of course, using our services to help you there. If you're running virtual private servers, VMs and EC2, you're responsible for making sure that your operating systems are patched, your network and firewall configurations are set up the way you intend them to. And finally, you're responsible for the applications that you build, the logic of those applications, and you're responsible for configuring identity and access management appropriately for your workloads. We give you the tools to do it, and then you'll configure them as you need. So are you ready to build? I hope so, because we've got a great program just after me for the rest of today for this Builders Online program today. We have 2 tracks in English, and as you saw in the opening video, we have something called the AWS Well-Architected Framework. And that's just a series of lenses to look at, or areas to think about when you're building applications. And a few pillars of the Well-Architected Framework. We've got track 1 touches more on performance efficiency and operational excellence concepts. It also covers how to use the AWS Marketplace to speed up your application development. So track 1 is a bit more about app development. Track 2 covers pillars around reliability and cost optimization. Also has some content specific for startups in there and remote work. So track 2 is more interesting to you for those reasons. Check it out there. We've got tracks across 4 different languages in English, in Korean, in Bahasa Indonesia, and in Vietnamese. And you have a chance to can do live Q&A with experts. So don't miss out on that unique opportunity. You can watch recorded videos anytime. So please ask us questions. We're here to help. This is what the agenda looks like for the whole day. So just after this, in the English sessions, we've got some Q&A with AWS experts up next. If you're already looking at one or interested in some of the other language sessions, Bahasa Indonesia, Vietnamese, or Korean, you've got a lot of sessions to choose from throughout the day there as well. We have breaks scheduled throughout, and we'll have a closing session at the end of the day. So stay with us for that too. I want to thank you again for taking your valuable time and giving it to me here to share with you the basics of cloud security today. I know you could be doing a lot with your day wherever you are in the world, and it means a lot that you chose to let me share with you. So thank you so much. If you want to keep in touch, if you have any other questions or things I can follow up with you on, don't hesitate to reach out. You can find me on LinkedIn or Twitter at Gabe Hollenby, and my email address is there too. So thanks again. Build on, and I can't wait to hear what you build. See ya.